Hello everyone. I think this is the last lecturing video for our class. And in this class, I will talk a little bit about the sensitivity analysis um, and how we use sensitivity analysis in our fundamental forecasting. And then I will wrap up chapter 9 and do some practice here. So the sensitivity analysis is that we try to find out the possible scenarios of the economic conditions, and then we try to analyze that under each possible scenario, what happened to our fundamental forecasting or models, what's the possible outcomes of those forecasting. So here is one example. We say that before. This is called instantaneous regression. So this Alcorn I just try to help you refresh your memory. This Alcorn use a model which is the instantaneous model to do the regression, to use the current inflation rate differential to predict the current quarter's exchange rate movement or percentage change. And there's another company called Mercer also use this model to predict or forecast the value of the British pound. And what they get is that the model B0, what they get, B0 is 0 and B1 is 0.7. So the model actually can write as the percentage change of British pound equals to 0 plus 0.7 times the inflation differential. And this, again, this mu t is error term. And we usually assume the average of the error term equals to 0. And this 0.7 of B1 suggests that for 1 unit percentage change in inflation differential in the current quarter, the British pound is expected to increase by 0.7%. If the inflation increased by 1%, then the percentage change of the British pound will appreciate against the US dollar by 0.7%. If the inflation differential current quarter decreased by 1%, then the British pound is expected to depreciate against the US dollar by 0.7%. So assume that it predicts the inflation differential is 2% for current quarter, then we can implant those 2% into this model here. We found out that the British pound, because the inflation differential increased by 2%, then the British pound will appreciate against the US dollar by 1.4%. And Mercy will, the professionals in Mercer may suggest that the economy conditions will have the different scenarios, and under different scenarios, the inflation differential will be different. And then here's this. So the possible scenario of this 25. The first possible scenario maybe is when economic is robust, is in recession. When the economy is in recession, the possible inflation differential of current quarter is 1%. And the probability of the recession is 25%, which means there's 25% probability that this quarter the economy is in recession. So this is at the beginning of the quarter. We don't know what happened in the future, but 25% of probability that the economy is in recession, and 50%, which is a very large chance that the economy is normal, and the possible inflation differential is 2%. And there's also 25% chance that the economy is robust. We are in a bull market, and the possible inflation is 4%. And then we can find out the expected British pound percentage change under each scenarios. So under the first scenario, when the economy is in recession, the possible inflation is 1%. So we plug this 1% into here. We found that the expected exchange rate movement is 0 plus 0.7 times 1% is 0.7%. And when the economy is in normal status, the possible inflation differential is 2%. And then we plug this 2% into this model, regression model again. We found that the expected exchange rate movement will be 0 plus 0.7 times 2%. So it's 1.4%. And then finally, in the last scenario, when the economy is robust, the possible inflation differential is 4%, and we again plug this 4% into this model, and the possible expected exchange rate movement will be 0 plus 0.7 times 4%, so it's 2.8%. And then we can find out the expected value, over all those scenarios. So the first scenario, the probability that this scenario happens is 25%, and times the possible and times the percentage change of British pound under these scenarios. And for the second scenario, the possibility that this scenario happens is 50%. And if this scenario happens, then the expected exchange rate movement will be 1.4. This is more like weighted average. We weight by the probability. And in the last scenario, which is when the economy is robust, and the possible the probability of this scenario happens is 25%, and it's if the economy is robust, then the expected exchange rate movement under this scenario is 2.8%. So then we found that the expected value is 1.5755%. So this is called a sensitivity analysis. We found out the different scenarios, and then we found out the expected value under different scenarios. Here's one more example. The following regression model was used to estimate the percentage change in Australian dollar. So Australian dollar movement percentage change in Australian dollar exchange rate is determined by A0, this is the intercept or constant term, plus the impact of current quarter's interest rate differential, plus previous quarter's inflation differential. And the MT here is the error term. And you should know the average error term equals to 0. And they found that the coefficient, the following regression coefficient here. So A0 is 0.001, A1 is negative 0.8, A2 is 0.5, and this inflation differential is 4%. But for this inflation differential is for sure. But the probability, the interest rate differential, it's not the same. It has different scenarios. So there's a 30% that Fed. Sorry. There's a 30% of probability that Fed will change we will set the interest rate that the interest rate differential is -5%. This is the interest rate differential. There's also 70% chance that the Fed will set the interest rate differential as -7. So there's two scenarios. And then we can plug those numbers into the model. So let's copy this model here. This model is the percentage change of the Australian dollar is 0.00. Let's look at here. A0 is 001 plus -0.8 times the interest rate differential. And plus +5 times the inflation differential over previous quarter. And with this 30% probability, and the Australian dollar, the possible interest rate differential is -5%. So the Australian, so here I write it here. So the Australian dollar will equals to 0.001001. So we plug this number. This number is for interest rate differential into the regression model, plus -0.8 times -5%, then plus 0.5 times the inflation differential in our previous in our problem shows that inflation differential is always 4% times 4%. So then we find out that the Australian dollar movement will be 0.061, which is 6.1%. There's a 70% of chance that the Australian dollar, which is interest rate differential is -7, and the percentage change in Australian dollar is 0.001 plus -0.8% times -7% plus 0.5 times 4%. And we will find out that with this, the second probability under second scenario, the Australian dollar percentage change will be 7.7%. Then we can find out the expected value will be 30% of the chance that the first scenario happens. And with the first scenario happens, the Australian dollar percentage change is 6.1%. And there's a 70% of chance that the second scenario happens. And under the second scenario, the Australian dollar percentage change is 7.7%. So the percentage change, the expected value for Australian percentage change is 7.22%. So that is the sensitivity analysis. And then after that, it's just some practice. Purchasing power parity is used as, of course, fundamental forecasting. I just show you the definition of those three forecasting methods. Technical forecasting using historical data to find a pattern. Fundamental forecasting using the relation between economic variables and the exchange rate movements. So basically, we can apply PPP, purchasing power parity, and the international Fisher's effect. Market-based forecasting basically uses spot rate or forward rate. The second question is that's the first question. The second question, if the speculators expect the spot rate of the yen in 90 days to be, so basically we need to be higher or lower, then we should hedge or not. So how could we solve this type of question? So we just do the analysis under the first choice, higher or lower. So if the speculator expect the spot rate of yen to be lower than the 60-day forward rate on yen. And in this case, because the spot rate is lower than forward rate, they will forward, let's focus on lower first. So let's focus on higher first because the ABC are all higher. So if the spot rate is higher than the forward rate, in this case, they can sell forward contract. Spot rate is higher than the forward rate. In this case, they will buy Japanese yen forward contract because forward rate is lower. They can buy at a lower price, sell at a higher price, and then the profit will be the strategy will be buy forward contract and then sell at the spot market. So in this case, they will put a upward pressure. So because they buy for the contract, is upward pressure on forward rate. So if we say expected spot rate is greater than the forward rate, so it's higher, then we know they will buy forward contract. This will put an upward pressure on the forward rate. So these three combination is the correct answer, which is A. If spot rate is lower than forward contract, then they will sell forward contract and buy at the spot market. Because they sell forward contract, this will put a downward pressure on the forward rate. So the correct combination should be lower sell and downward pressure. So the correct answer is A. Next one, assume that US annual inflation equals to 8%. Japan's annual inflation is 5%. And if purchasing power parity is used to forecast the future spot rate. So basically, US is 8% and Japan annual inflation rate is 5%. So the future spot movement will be upward. So the percentage change in the exchange rate of yen will be around 3%. So basically, that's an appreciation of yen's value over next year. Leila used the following regression model to determine the forecast over the last 10 years. And when S is the spot rate and Ft-1 is the forward rate of the yen in year T-1. And they found that A0 equals to 0. A1 is 1.3. So which means the spot rate is always greater than forecasted value. So which means it's underestimated. So here is some data. This is the case when A1 greater than 1. When the forecasted value is 1, the realized value is 1.3. The forecasted value is 1.2. The realized value is 1.56. If the forecasted value is 2, the realized value is 2.6. So the realized value is always greater than the forecasted value. So which means the realized value is underestimated by the model. Most call experts exports products to Japan denominated in yen. If the forecast value of yen is substantially, again, this is the same thing. If the forecast value is substantially higher than the forward rate. Remember here, when they export products to Japan, they will receive Japanese yen. They want to sell at a higher price. If the forecasted value of yen is substantially higher than the forward rate, then which means they prefer to sell at the spot market, so they will decide not to hedge. And if the forecasted value is lower than the forward rate, this is when they need to hedge the risk. They will have to hedge the risk because if they do not buy forward the contract, they will have to sell their Japanese yen receivables at the spot market, which the price is much lower than the forward rate. They will receive less US dollar cash flows. That's chapter 9 and basically all the lecture videos. And if you have any question, you can let me know. Feel free to send me emails and we can schedule online meetings. Thank you for watching. Bye.